Let me refrain. Let me go back and show the, put it on recording. There's a question. Leave that on there for a few seconds. For the video. And of course you can pause it, so I've left it up there long enough. All right. Now, mean, median, mode, range, mid-range, and variance, and standard deviation. And if you want to, you can copy those down. Well, go ahead and fill them out and we'll copy them down. So the mean is going to be equal to, well, we need to put these in order. So I'm going to put these in order right here, and I'm going to put them in descending order. So I'm going to go to data. Now, when this happens, I didn't highlight A, B, C, and D because I don't want the computer to put that in order. Okay? So I highlight what I want to put in order, and then I expand the selection, and it'll put these in order according to these numbers. Everybody with me? See? Same thing down here. Sort and expand. All right, so there's our numbers. Okay, mean, we're going to go ahead and do our summation of these numbers divided by how many numbers? 6?
Yes, sir.
And that's the mean. Median is going to be between those two numbers right there, which is equal to parentheses this number plus this number divided by 2. I don't care about the mode, and it's to the decimals. You're not going to get many modes when you got decimal places, especially the further you go with the decimal places. This is to the tenths. It's hard to get two numbers to equal the same in a tenths or hundredths or a thousandth situation. So most of the time when you got decimals, unless it's really purposely done by somebody making up a problem, you're not going to get too many modes with decimals. So I'm just going to put NA. Range is equal to the highest minus what? Lowest. And I forgot to color that yellow. Mid-range, parentheses, is equal to the highest plus the lowest, or the lowest plus the highest, divided by 2. And then the variance is going to be equal to, well, we got to do x minus x bar. So that's going to be equal to 104.9 minus the mean, F4. Remember, hit F4 to lock the mean. And copy that down. Then x minus x bar, quantity squared. That's going to be each one of those raised to the second power. And see, one of the reasons I use the Excel spreadsheet, not only to get everything on one board, but it also helps you to see what actually goes behind the calculation.
Did you not right when I totaled it up? I didn't.
Good. Let's see what happens. Total it up, and there is your numerator for the variance. So equals this divided by, what's 6 minus 1? 5, Hubert. Thank you, class. So there's the variance, and then raise that to the what power? 0.5 power. And there is your standard deviation. So I'm going to go right here, and I'm going to put the mean in the middle. And I'm going to color that per day. Color that per day. And I'm going to color that aqua color. And needs to be that aqua color. Needs to be that aqua color. So I'm going to take 157.9 and I'm going to add the standard deviation and lock that. And copy that over 3 times. F4. F4 locks it. Because when you scroll to the right or scroll down, when you copy down or copy to the right, it's going to take, if you don't lock it, where you add this, it's going to, since I'm moving over to the right, it's going to add this one next. And it's going to add that one next. So you got to tell it not to do that. Just like when I did right here, when I did x minus x bar, if I copy that down and I don't lock mean, it's going to do 123 minus 131, and it's going to do 128 minus NA, and you'll get an error. 134 minus 210, 141 minus 209, and so on. So you have to lock it.
Okay.
So equals this minus the mean, and again you got to lock it. Oh, I'm sorry, I'm sorry, I did something. I think I minus the mean. I'm sorry. I suck. Okay, that's going to be H12 minus that, and then F4. There we go. And then copy that to the left. And now you have your normal distribution. And you can draw that, you can set up your empirical rule if the question asks it. But what they're wanting you to do is compare the numbers is what you want to do. So I'm going to take this, I'm going to highlight all this, Control C, probably won't do all of it, but do a good portion of it. Looks like it did.
Okay.
Okay. Now, the first thing I want to talk about is this right here. I'm going to highlight this, another color. I'm going to highlight it kind of a reddish color. And this down here, kind of a reddish color. Because they're going to ask you to compare those two things. Now, what did I tell you standard deviation meant when we first started covering standard deviation? Spread. Okay, if you got a large standard deviation, that means you got a wider what? Spread. That means your numbers are what? They got gaps in them. If you got a smaller standard deviation, that means the spread is not as big. That means the numbers are what? Closer together. They're closer together. They're more tight. So, which one has the larger standard deviation? The first group. Okay, so that means the numbers are more various in the first group. And I think that's probably what the question's going to ask. Besides, what is the mean, what is the standard deviation, and all that stuff, they're going to ask you which one is the better set of data. And you would say the better set of data is the Midwest. Also, you look at the middle. Mean is 157, median is 131, mid-range is 209. Where down here, the median is 115, mean and median, they're close. What's the difference between these two? 95 and 115. Is that 20?
Yes.
Okay, what's the difference here?
20, so almost 20.
It's what?
A little over 20.
A little over 20. So that's pretty close, but let's look at the mid-range. 210, and the mid-range down here is 157. So again, you see a bigger spread here than you do between 116 and 158. All right. Basically, everything turns to the Midwest being a little bit better data than the East Coast. So let's see. I don't know what all those questions are going to ask. I'm not going to answer all of them because I'm not going to go back and forth to the spreadsheet. Let's see. It's asking for the mean. It's asking for the median, the range. Okay, they want a 5-number summary, so let's do a 5-number summary. I think it's ridiculous to do a 5-number summary for 6 numbers, but we'll do it. Let's go back to the 5-number summary. Let's go back and we'll do a 5-number summary. So right here, go away. Right here, we'll do a 5-number summary. I don't want to do it there, but we'll do it. 5-number summary. Okay, 5-number summary consists of the mean, the first quartile, the second quartile, the third quartile, and the what? Max. And of course, you got the max. The max is equal to that number. The mean is equal to that number. And the second is equal to what?
It's the...
And I will color that yellow. And we'll color this kind of a grayish color. And we'll color this kind of a baby blue or something like that. All right, so now you just got to find the first and the third quartile. But to do that, where is the median? The median is right here. So how many numbers are above that red dot? Nope. 1, 2,
3.
3. Is 3 odd or even?
Odd.
So you just pick the middle of those 3 numbers. And the middle of those 3 numbers will be what? 123. So I'm going to highlight that. I don't know why this. Okay, I'm going to highlight that one. I'm going to highlight it something. That purple is too purple. Can't see the number. Yeah, let's go with that fuchsia. Ooh, that's different. And fuchsia. Somebody want to get that color closer to another color, or is it fuchsia? Looks like fuchsia to me. Okay, how many numbers are above the red dot? 3. So we pick the middle number, which is 141. And we'll color that a lime green. Well, I do it for you. I do it for y'all. I do all these things for y'all. See how blessed y'all are. Now I don't have posters. I'm sorry, but you can put that in evaluation that I'm not an innovative teacher because I don't use posters. You can put that in your evaluations, okay? Because it's all about innovation here at Tri-County Tech. Y'all got that? Posters. All right, now I want you to draw the number line over here, and we'll go ahead and copy that down right here. We'll copy it. I don't know if it will copy, but we'll try to do the best we can and put it right here. I think I messed up. No, it's not supposed to be there. It's just one line down. Oh man, I just can't. Y'all ever felt Monday on a Friday before? I feel like it's Monday. Maybe it's vodka will help. Oh yeah, that vodka helps. Oh, I'm an alcoholic. I guarantee you somebody's gonna call my boss and tell that I drink every morning, just based off of what I say. You know, you got people that just want to cause problems. Listen, I'm gonna tell you something. This is 20 ounces, okay? Actually, it's more than 20 ounces because the lid holds about 5 or 6 ounces. So that's 26 ounces. If I drink 20, let's say a third of that would be vodka, okay? So a third of 21 is 7. If I drank 7 ounces of vodka every morning, my liver would be a pickle. I don't think I could. I don't see how people drink in the morning. I can't do that. I did that in the Marine Corps, but that was just, you know, that's rough. All right, I'll shut up. So 105 is right here, and 315 is right here. And what do we put in the middle?
131.
The mid-range, which is the mid-range.
209.
209. 210. All right, now y'all graduate that. Somebody graduate that. You got to do the middle of the middle of the middle of the middle. So what's 105 plus 210? 315. Half of 315 is what? 157? Y'all check me. 210 plus, that's 525. Half of 525 is 562 or 262. Y'all check my math.
You said 565?
Take 210 plus 315. What do you get?
525.
Divide that by 2.
262.
It's a miracle. 105 plus 210.
262.5.
Divide by 2. Okay, now find the middle of those 5 numbers. 105 plus 157 divided by 2. 157 plus 210 divided by 2.
The first one's 131.
Okay, the first one is 131. What's the second one?
180.
183. What's the third one? 236. And the last one?
288.
Okay, now I don't have any more room. How far can you do the graduations? Infinite. If you want to make that number line as big as your piece of paper, that's fine, and you can get it into 50 or 60 graduations if you want to. But there's no use in it. That's pretty much good enough, but I don't have any more room. But I could do 105 plus 131, or 5 to 30 is 25, half of 25 is 12, so that middle one would be 117. See what I'm saying?
Yeah.
Just add 12. 12 plus 131 is what? 143. 12 plus 157 is 169, and so on. So you could do that again. I'm not going to do it. But anyway, I did the max, I did the min, and I did the what? The mid-range. What's left?
The middle.
Which is the box plot. So I'm going to take my handy-dandy, I don't know what color I can get to match that fuchsia. I'll try this one. And that's going to be 123. 123. Whew. What did I say was between here? 127? Yeah, 127 or 117.
Yeah.
So 123 would be right in there. Okay, the other color is green, verde. And that's going to be 142. Ugh. 142 is right there. And then what's the middle? 131. And what is all statistics compared to? The what? the middle, or the center. And we know this looks like what? Severely skewed what?
Right.
Severely skewed right, because all the data is where?
The right side.
On the left.
On the left.
It's always the opposite. Now, why is that? Because of this 314. See, this 314 is out of Wampus. And it's out of Wampus, it makes the other ones look small, right? The higher this number is, the lower these numbers look. So that's why you got this box way over here. All right, now do the second set. Do the second box plot. I'll move it up. I'm going to put the other one right up under that one so you can see the difference between the two. It would be best if I did a poster and showed y'all, but I'm just a dinosaur. I got kudos the other day, y'all. Y'all were here when I taught from home, wasn't you?
Mm-hmm.
Yeah.
Well, I wasn't here, but I
Well, Easley, guy came in there and took a picture. You think Easley told me? No, Easley didn't tell me. Did y'all see that guy taking a picture?
I didn't see him taking a picture. I saw him standing in the doorway, though.
Oh, he did. He took a picture. He's a vice president. He took a picture and sent it all around. I got a big attaboy. But I didn't have posters. So.
Do you want me to make you posters? Because I can make you posters.
No, don't, because you'd have to go out and find poster board. They still sell it.
Oh, please, dollar store.
They still sell it.
Cheap.
Oh,
It's
okay.
like-
Because last time I did a poster was probably in what, 3rd, 4th grade.
I'm going to get you some.
That's
We're
some
gonna
innovative stuff, though. Let me tell you. All right. So let's take our 88 and we put it down here. Now, a lot of you are saying, well, why ain't Hubert using the decimal? Is it necessary on this number line? Why?
It's close enough.
Because it's close enough for government work. What are you doing? Are you figuring out the diameter for a rubber O-ring on the space shuttle? No. You're putting a box plot on a number line, okay? You don't need to worry about those decimals. Now, if they ask for the min, then you put the decimal. But if you're just putting a box plot, if you're trying to see what this looks like on your paper, then don't worry about the decimal. And the max is 228. And the mid-range is 158. Okay, start graduating. And I'm going to mark these 3 out, because that's the number line. Ooh, this is going to be easy, because 88 to 158 is what, 70?
Mm.
Half of 70 is 35. 35, I have no, 120, 123. What's the middle here?
123.
What did I say, 35? 35 there would be, what, 193? Oh, quit yawning now. This is exciting stuff. All right.
I know.
All right, so half of 35 is what? Half of 34 is 17. So let's add 17 to be what? 17 to be dang old 105. Y'all check me. 17 here be 140. 17 here be 175.
Yep. I got that.
17 here would be, well, 200 would be 217 minus 7, 210.
Yep.
All right, is that close enough? I hope it is. So I'm going to take my fuchsia. If y'all see an error, just let me know. 93. 93 is going to be down here somewhere. The green is 98. 98 is not, well, I got to move it to the left a little bit. Basically, it's going to be even smaller than this one. 94, but what does the smaller box see? That says the data is more what? Tight. The data is more tight because the box on your box plot is what? Smaller. Is it still skewed left or skewed right? Yes. But the box plot is smaller, so this means the data is more what? More tight. So all indications say basically that the Midwest is better what? Better numbers. So let's see what the rest of the question is asking. Does anybody have a question on those?
I have a quick question.
Yes, ma'am.
When you say skewed, can you like briefly explain that?
Yeah. Hold on. Let me go to the whiteboard.
Okay.
There's 3 distributions. Well, actually, there's 4. Here they are. 1 is the normal curve. That's when everything is supposed, there's no outliers, there's no 6 foot second graders, there's no 1900 SATers, everything's normal. Uniform distribution. Uniform distribution is when there's no variance. And that is called what? Time. Why is time uniform? Because we cannot what? We can't change it, we can't control it, we can't manipulate it. If you really think about it, time is one of those things that is just, you can control everything, but you can't control time. That's why it's a box. The third is when all the data, and we're comparing it to center, everything's compared to what? Center. And you can put the center here, you can put it right here, but it doesn't matter where you put it because time stays the same, so that don't really matter. All the data is where? Over here. And then you got 1 or 2 pieces over here. And that is skewed right. It's always the opposite of where the data is. Okay? And of course, the next one would be skewed left. I think I went over this, and Miss Riddle, you might have been, I don't know if you were, hungover or drunk or whatever, I don't know, but whenever you have the center right here, and you have all the data over here, that's what? That's skewed what?
Left.
Skewed left. Do you remember me going over the easy test and the hard test? Do y'all remember me going over that? Yes, no, maybe? I've got one person that said yes.
Yeah.
Okay, that's where we talked about this. Which one is this one? Everybody flunked the test because this is the average. This is a C. Okay, everybody flunked the test. Remember me saying that's probably because the teacher sucked, okay, the student sucked, or a combination of what? Hard test. Remember that I was saying the test was invalid, meaning that the teacher accidentally pulled chapter 5 out of the filing cabinet instead of chapter 4, or the teacher did not cover the material, or the students didn't what?
Study.
The students didn't study. So what's the opposite of a very difficult test or an invalid test or the students not studying or the teacher not going over the material? Easy test, meaning that the test is valid, everybody studied, or the teacher covered everything. So that's the difference between the skewed and the normal. Does that help?
Yes.
Okay. So that covers that. Let's go back to the question, and I'm not trying to waste time. I'm just trying to cover the question. So let's go back to the question. Let me get out of this. And I have to erase this. I can't get rid of it, so. And it does the lower quartiles. Y'all check my numbers. Somebody, let's see, which one is this one? This is the East Coast. Okay, somebody give me the numbers for the East Coast. What's the low value?
104.5.
What's the median?
131.5.
What?
0.5.
0.5. What's the high value? 314.9.
Yeah.
All right. What's the first quartile? 123.3. And what's the third quartile?
141.6.
Okay. Now see, if this book was worth a crap, which it's not, it would say men, and it would put it in the order of the 5-number summary. Men, first quartile, second quartile, third quartile, and what? Max. 99.9% of your books are going to do it the way that I did it. Okay? This book sucks. But I could have told you that. Okay, what do they say? What do I do? Let me narrow this down so I can see the actual question. Check. Okay? Now, probably I've got a decimal off. Maybe. Okay, let's see what they say the answer is.
You gotta round to another place. That's stupid. See, mine did that too. On one of my
It's like I said, this book is stupid. All right. So what did our East Coast look like? Now, see, the East Coast and the Midwest, they should put the two together so you can actually compare them. But what you're looking for, first of all, you can't have this. Why?
There's no, in bars.
Exactly. So B is not it. So you take your handy dandy X and you put through that. That's not it. So then it leaves this, and it leaves this, and you might have to pull it up and make it bigger a little bit to actually see the difference. So, like that. And then pull this one up. One more. Okay, it looks like to me, I'm going to take my handy dandy vertical line because something's different between the two. So I'm just going to take my vertical line right here, make it as vertical as possible, and I'm going to move it. Hold on a second. All right, it looks like to me that that's around, what, 130, let's see, 135, let's see, 30 to 70 is 40, that's 150, so that's about 149. And this one right here says that the first quartile is about 127 or something like that. So on the East Coast, what was the first quartile?
123.
So that one's it. So the answer is what? A. So you go back down. I'm trying to find my way around this thing. I've got it blown up, so just bear with me a second. Okay, there we go. So A, and then final check. Okay. All right, somebody give me the Midwest. Give me the low value.
87.8.
87.80. What is the mean? We're going to do it the right way. What's the first quartile?
92.6.
92.60. What's the second quartile?
94.90.
Third quartile?
96.6.
And the max, that's 228.10. All right, we got it right because we put a 0 behind the numbers. All right, which one is it not? It's not B. Why? Well, we don't even have a dadgum. We don't have anything right here. We don't have a what? We don't have an end on the right. So B's not it. I don't know. Both of these look kind of funky. I don't know what they're doing on these two. So we're going to blow it up and see if it gets better. So let's blow this one up. Now that one looks funky. Let's see what this one looks like. You might just have to add it up. I mean, get it as close as you can. All right, let's take the handy dandy. It looks like to me that they're putting the first quartile. Let's see, this is 80 to 120 is 40, so that's 100. 120, so that's 110, maybe 105 right there. And then over here, I can't tell where they're putting it. They're putting it at about, let's see, that's 80, that's 100, so 90. What'd I say over here, 100 and what?
105.
I said 105 and 90. What is the first quartile?
87.
So it'd be this one, right? So, and sometimes you can't tell with these box plots, and that's why you have to look at several different things. Got it right. Okay, and I'm not doing the stuff. Oh Lord, A through freaking Z. This problem, I try not to put this problem on the test. I hope I didn't. All right, what is the East Coast standard deviation? 77.91. And somebody get ready for the Midwest. The Midwest is what? What's the Midwest, somebody?
71.83.
And now they're going to ask which, okay, whatever, it's a rounding. I'm not worried about it because I know mine's probably right. No, it's not. Okay, that means my spreadsheet, let's go back. My spreadsheet must be off. Let me check my spreadsheet right quick. Let's go with the mean. Sorry about that. And add all these up. Divide by 6. So that's why you got to watch when you copy and paste. You got to watch. 115. And I'm going to take 115 away from each one. Equals this minus 115. F4. Copy. Yep. That's why you got to watch it. I should have checked. There we go. Which one has the best standard deviation? The smallest. It's still Midwest. Okay. Now it's going to change that's going to change the box plot. It's going to change it considerably. But we already did the box plot, so don't worry about it. Which the box plot, yeah, it's not going to change it very because it doesn't use the standard deviation. So the box plot is still okay. So 55.09, that's where that comes from. So I messed up there, sorry. And the standard deviation is approximately, okay, I'm not going to do the rule range of thumb, but the rule range of thumb is you take the highest plus the lowest and divide by 4. Okay? Or you take the highest minus the lowest and divide by 4. And that's supposed to be, but I'm not going to do that. Somebody take the highest minus the lowest and divide by 4 on the East Coast. It should be 104.95. But I haven't done the rule range of thumb in a long time, so I may be wrong. range divided by 4. Did I not do that? Somebody take the high minus the low and divide by 4. I thought it was right.
52.5.
Huh?
52.5.
Okay, I don't know where you...
I don't know what I did either.
Yeah, thanks. 52.5.
Oh, I added it. That's what it was.
Okay,
I didn't-
52.5.
Yes.
And do that. You don't use the rule range of thumb very much, but it's basically going to say that the second one, the Midwest, is smaller. But go ahead and do the Midwest. 228.1 minus what? 87.8 and divide by 4. What do you get?
35.
I'm sorry, what?
35.075.
Which one is smaller? Midwest. So the Midwest is better data. I don't know why they're drawing all this out, but how well does the rule briefly discussed? It works well. Y'all read those. We're gonna say it works well.
I think it's B. Said I think it's B.
B. Okay. Nope. C.
When it's A.
I'm not going to sit here and read them. They do not work well because they are outliers. Yeah, there are. They're outliers. The outliers 314 and 228. But just put they do not work well. I'm not worried about that. Based on the results, compare and discuss the two sets. Basically, the East Coast data is looser than the Midwest. So some of y'all read that and tell me which one says that. That means that the East Coast has more variation than the Midwest. It looks like it's going to be...
It's either A or B.
It's higher for 6 Midwest, which means the level
It's A.
of...
A.
I would say A.
It's A and C.
It's what?
A and C.
A and C? You can't pick both. Oh, you
Yeah,
can?
just like all that apply.
Thank you. Okay, I'm glad y'all read that. So basically you're comparing them, but what it comes down to is that cost of living index. The Midwest has a better set of data than the East Coast. Okay? This question is not a test question. Did y'all take the test? Did y'all see one like this on the test?
I did not see one like this.
Okay, what about y'all?
No.
Okay, I would not put this on test because it's too much. If I was to put this on the test, it would be the only question on the test because there's so many parts. It's just ridiculous. I do not like this question as a homework question or as a test question. I like it if they just cut out all these questions and say, based on the statistics, which one has the better set of data? Midwest. That's the best. That would be a good test question. But not all this. This is ridiculous. Agreed? Okay. All right. We're gonna shut her off, and y'all have a good weekend. And y'all don't have anything to do. The only thing I would suggest you do is read up on probability and causality. We'll go over that when y'all come back. When? Monday?
Okay, I have a question. I got an email saying that the college is closed on Tuesday.
Yeah, we got to go study those posters.
So why would they do it on Monday? So we do have class Monday.
Yes, you have
Okay.
class Monday. We don't have class Tuesday because we got to go up there and learn about posters.